Hello, everyone. Welcome to the Columbus JavaScript User Group, or ColumbusJS, as we're trying to rebrand it. My name is Guy Royce. I'm the self-proclaimed czar of the JavaScript group here. And tonight we've got Jackie Gleason, who's going to be speaking to us on robotics and Node, which are two topics that I'm very fond of. I don't know if for the people that have been here for a while, that have been around the JavaScript group for a while, we would occasionally have a hardware hack night. Where we'd bring our Arduinos and our Raspberry Pis and our stepper motors and hook them up and do fun, silly, ridiculous stuff for a few hours. We haven't done one of those in a while because we haven't, but also because we can't go and meet these things physically and do these. But so this is a kind of topic I really like, and so I'm excited to see what Jackie has to say tonight. Before I hand this off to him, I do want to just say how this is going to work. So we've got as you can see, we got a Zoom going here, and there's 6 of us here in Zoom. If you want to join us in Zoom, there is a URL. If you go to meetup.com, you should be able to get it, and I'll go ahead and post it. It's also posted in Discord, and if you're not in Discord, you should be. And so I'm going to post the Discord URL up on here in Zoom, and also up here on Twitch. So if you want to join us on Discord, you can. Jackie's going to talk here in just about a minute once I'm done yammering. And if you have questions, we can put them in chat in Zoom, or you can put them in chat on Twitch. I'll keep an eye on those, and I'll share them with Jackie at an appropriate time. If you're in the Zoom already and you want to ask Jackie a question, you can just ask. I mean, don't talk over him, be polite, but just unmute yourself at an appropriate time and ask, and I'm sure he'll be happy to answer your questions. So. Or you can put them in the chat as well. So, yeah, that's pretty much all I got. So I'm going to hand it over to you, Jackie. Let's give him a big virtual round of applause.
Definitely. All right. So can everybody see my screen right now? All right, good. I see a couple nods, so I'm going to hope that means yes. All right. So my name's Jackie, and what we're going to do is we're going to talk about robots with Node, and nowadays the whole topic of robots is a little different. So I wanted to be a little bit more specific and talk about physical robots. So who am I? I work for Chase. I do some JavaScript and a lot of Java for them, doing a lot of search algorithms and things like that, implementing them, AI modeling, stuff like that. But when we're talking about this is more of my kind of like Guy was saying, more of my passion than it is my my employment. So what are we going to talk about? So I wanted to define that up front. We'll start by defining what we're talking about in terms of robots. Then we'll look at how we can use Node to develop one. And finally, we'll look at next steps. So, okay, now we've got a basic LED, we've got a basic stepper motor working. What are the next steps? What are the next things that we should look into, right? So that's what we're going to do. So for the definition of a robot, there's a couple terms here. Basically, there's a mechanical device that sometimes resembles a human, capable of a variety of complex human tasks, a machine that operates by remote control, and one that works mechanically without original thought. So the first two we're going to kind of look at, except for maybe the resemblance part. But the last one is more of an AI topic. And I think it'd be a great topic to have, but not. It was so hard kind of quantifying what I should put into this topic that I kind of left that out. But maybe for next time, if there's enough interest, we can do a topic more on how we implement AI models and things like that in the mix. So, oh man, picture didn't work. Oh, there it goes. All right. So I want to start by going way back. I mean, working as Guy said, working with a Node and robotics is not the newest thing. I gave a talk on this back in 2011. The first idea of the smart home was in 1999. And, basically the whole idea is, giving everything. We've kind of come to this point where basically everything in your house is given an address. And especially between 2011 and now, we can really see that transition, where everything's kind of getting an address. And so as that happens, understanding serial communication and things like that really become important. I'm still waiting on my Android powered microwave, but I'm sure there's one somewhere still. But so, it's time for the robot assistant revolution. We've all seen it where we're using our Alexas more. We're dealing with things where we want to make sure that we have a smart home, we have multiple thermostats. We want to be able to make sure that something's automating how that's working. If we want to send something to go do a task or something like that, drones and things like that. All of this becomes part of what's coming around in terms of the robot assistant revolution. So I'm sure I'm going to leave this because we don't really have a good way to raise hands. I'm going to kind of ignore the raising hands portion of this and just kind of talk about node bots. So again, this has been around for a while. So what we're going to kind of talk about here is if you guys have seen it before, is node bots. Now, a lot of what that kind of term kind of weighs is using Johnny 5. I'm not going to get into that necessarily today. That's kind of like the next step thing. I want to talk more about basic communication and things like that using Node. So that's kind of where this talk goes. But I definitely think there's a lot more subject matter. And if we decide that things are interesting, we can definitely look at putting together presentations on other sides of this, right? So, so when I'm defining my robot today, we're going to define it as an expandable skateboard robot. So similar to how the electric cars are and things today, where you just basically make a platform and then you start building on top of it. I chose to use a two-wheeled solution just to make it simpler. But you can do the same thing with four wheels. It's just a matter of kind of scaling it to what you need. In order to be able to interface with this robot, I decided that what I wanted to do is I wanted to be able to use an HTTP interface. So what that means is when the application is running on the actual robot itself, we communicate with it. We tell it to go forward, backward, whatever we want it to do through an HTTP interface, basically like a RESTful style interface. For the components for this robot that we're going to build today, we're going to look at using an LED. That basically is for status, things like that. And we'll look at motors. We'll also talk a little bit about sensors and how those integrate. But the main crux of this is just to kind of get to that beginner mindset, right? Because I didn't know my crowd, and I'm trying to just go that direction, right? So we'll talk a little bit about IC components. We'll talk about Arduinos. We'll talk about Fermata for if anybody's familiar with that. We'll talk about different serial port interfaces using SPI or using I2C buses, things like that, and other cool add-ons. So I believe this is the link, if I'm not mistaken, for the GitHub repository. So I have a GitHub repository for this where you can find most of the code that we use today. So if you have questions or if you want to fork it and kind of play around with it, feel free. And that should be the GitHub repository for that. Again, I'm not an electrical engineer, so my fritzing diagrams and things like that, please don't criticize them. That's not the point of this talk. The point of this talk is more how do we interface with, how do we use Node to interface with these types of interfaces. So just don't try to do, if you blow up a sensor or something like that, because it doesn't have the right resistor on it. I'm not trying to get into that tonight. So, so as we said, I started out with a pretty simple chassis. Part of the idea of this is I wanted to make it as inexpensive as possible. So it'd be fairly easy for people to recreate. This chassis on Amazon was really nice because, as you can see here, it came with the plastic part was a little bit, mine came all scratched up and it was a little bit low quality, I guess. So that part I kind of threw away, but the wheels were nice and the battery pack was nice for the price. So and the motors. So I went ahead and took this on. And long story short, I ended up having a 3D printer later on. So I replaced the plastic parts with actual a 3D printed design that's available on Thingiverse if you decide to actually try this yourself, which I have right here. Okay, so I forgot to put the slide in. Right, so I actually took that, I converted it over to a Thingiverse a file, and then I went ahead and and use that instead of the plastic portion. So why JavaScript? I mean, a lot of times when people do this, they use Python, but I tend to use JavaScript a lot of times because it's just a scripting language, so you can, kind of change things on the fly, same as Python. There's still a lot of really good libraries, especially, we'll get into this a little later, but when you're talking about things like transitions and things like that, there's been a lot of JavaScript transitions that have been created. So you can leverage those for a lot of different things when you're trying to, take a sensor and move it in a certain way, or sensor, move it in a certain way, things like that. So those are nice as well. Or an example we'll use later, taking a color string and converting it into an RGB code. There's a really nice JavaScript library for that, right? So it's super easy to be able to handle that through JavaScript. Relatively easy native library integration. So we'll talk about this a little bit later, but you can call any C or C++ class application shared object that you would want to be able to call, same as you would with Python. And this is a JS meetup, so it kind of makes sense to talk about Node as opposed to Python. So that's another reason. So first we'll talk about the brain of the robot. For my robot, I decided to use the Raspberry Pi. There's plenty of cheaper alternatives like the Banana Pi and stuff like that. But I decided to use the Raspberry Pi because it had the built-in Wi-Fi and everything that I needed to be able to get everything working pretty quickly. So that's what we're going to use for this individual tutorial. My version was a Raspberry Pi 3, so it's a little bit older, but it was all I really needed, so it worked fine. Again, so Raspberry Pis, when you're going to start talking about connecting to kind of things like motors or LEDs or things that you wire into a breadboard, the way that you're going to pretty much connect those things is going to be through this 40-pin adapter off to the right of the board. And you can see here, some of these are providing power to the actual unit. So if you need 5-volt power, you can tap right into the 2-pin. If you need the I2C communication, you've got the pins right here. If you need regular GPIO communication, a couple of the other the protocols that I'm not as familiar with, things like that, you typically tap in them through here. And as you can see, they're labeled. There's differences between the number right here and this. We'll talk a little bit about that later. But this is where you'll typically tap into to be able to control anything that you want. You can see that these are limited. There's only a certain amount of them. And that's where things like the I2C buses and stuff like that come into play. I2C, however you pronounce it, I don't know. So that's where you would start to use that if you were trying to do things that were a little bit more complicated or needed more addresses than what you could provide through these GPIO pins. All right, so the first step we want to do is we want to set it up. In my example, it was basically just a regular Raspberry Pi setup. You went ahead and set up the Wi-Fi. I use the light version of Raspberry Pi because I don't see any need for the desktop or anything like that, especially when you're talking about something like a robot, right? But if you prefer, if you want to VNC into your robot, by all means, or anything like that. So I pretty much set it up, upgrade the libraries like we need to, install build essential, and then configure SSH. I also typically configure HTTPD just so that I can forward the rewrite the address so that I can use port 80 instead of port 3000. But that's a little extra work and a little bit outside of the scope of this meetup, so I'm going to put that on the back burner. Again, network setup, and then any kind of SSH keys or things like that that you need to set up. So how do you install Node? There's two ways to do it. You can either do it from source. Since we're talking about robots, I would probably advise against this way, mainly because I tend to, on my personal box, I tend to install Node from source. But when you're talking about trying to have to use header files for some of the native libraries that help Node interface with some of these native languages, it's probably better to just use the package manager. So to do that, we install the source, and then we go ahead, and then once we've got that updated, because we're talking about Raspbian here, Raspberry Pi, I'm expecting it to be Debian. So I think that that's a pretty obvious assumption. If you're using something other than Debian, might be a little bit different. But these two commands between the adding of the actual repository information, and then the actual installing of the Node.js library, super easy, 2 commands, pretty easy to get going. So now once you've got everything there, a good idea is to make sure everything's working. I would start by SSHing into the Raspberry Pi, then clone the repository. Once you get there, you would cd into the repository directory, then cd into robot node UI. There's a little bit of a typo there where it doesn't show the actual repository address, it just has the period. So the assumption there is that you're in the repository directory. Run the npm install. So for the example that we're showing here, I've got it using a library that requires you to run as sudo. So that's why I have that brought out here. I would advise against that, and that's kind of a whole another talk in and of itself. If you're going to bring something into production, there's certain other ways that you can handle that. But for simplicity's sake, it was just easier to just show doing sudo. So the assumption here is that the library that we're using uses sudo access. And then once you've done that, you should be able to confirm the site's accessible. And we'll go through all this in just a minute. And so how are we interfacing with this? And actually, hold on one second, because I can't see this. So first, what we're going to do is we're going to have a client, right? That client is going to call into Koa or Express, which is going to be our, our HTTP layer, what's handling the actual TCP call in. That will translate to Node, and then Node will translate that into native library calls that then interface with C or C++ libraries. So that's the basic interface. A lot of the compiling for all of these interfaces, it'll typically happen during the install phase. So when you run npm install, sorry, my bad. When you run npm install, it'll go ahead and recompile any files that need to be compiled. So there's a few different applications you can use to do this, and I wanted to show examples of a lot of them. One of the fastest libraries you can use is RPIO. So this is an example of what that looks like. You can see that it's fairly simple. You basically just, with this one, you're just opening a pin. So if you remember back a little bit when we had this diagram, you can see that there's a 16 pin, which would align to 23. So that's what's being opened right now in here. And then it's an output, which means that we're going to write to it. We're not going to read from it. And then finally, we're setting it to low, which means it's low. It's 0, not 1, basically, right? So it's the no energy instead of the voltage. And then for that, we'll write every 1 second. We'll write the high voltage, wait a second, and then we'll write the low voltage, and then sleep again for a half second, right? So that's what this is doing. You can see right now where this is, not much code to get an LED working, right? So it's super quick, super easy to get up and running. What I'm going to actually use for my demo is a library called Pi GPIO. So this is an example of a similar thing. One of the first things I wanted to point out is if you see here, the number is 24 instead of 16. If we go back and look, hopefully I did this right. Actually, I think it's, if we go back and look and we see, I actually messed it up. It should be 23. But you can see here where it was using the 16 value, and this library is using the GPIO value. So so that's a big difference. So if you see one using one value and one using another, and they're writing the same, or they're turning on or off the same light, or turning on or off the same motor, that's because sometimes they can be the actual GPIO number, and sometimes they can be the pin number on the Raspberry Pi. So be careful about that a little bit. But you'll see here where on this one I've kind of made more of a class pattern here. I've created an LED object that defaults to port 20 or pin 24. Set that to a local state variable, which is kind of unnecessary, but I do it anyway. And then I go ahead and configure the GPIO pin that I need. And for basic configuration, you can see that the basic configuration is just saying that it's an output pin. And then what I can do is I can go ahead and start writing to it. So I can write low, which means that we're turning it down, or we can write high, which means we're turning up the electricity on the actual pin. And then we have another one here where we do a blink, where we do a delay, and then we set a timeout, right? So all of this stuff is extremely easy to do and doesn't require hardly any code at all. And if you run a simple script like this, like you see on the right, and you just run it under sudo because it needs sudo to be able to access the GPIO pins, then it will go ahead and it'll actually blink your blue LED there. And we'll see a little bit of this here in a little bit. What I put in here is I put in a fritzing diagram, which is it's a open source application that you can use to actually diagram out what your circuits look like, and I believe this is correct. So, but you can see here where we're actually connecting an LED into it, and then that's how you can go ahead and run these. Again, it looks like I have a typo on one of the pins, but I'll get back to that and I'll correct that. So now that we got our light working, the next thing we want to do is we want to add movement. And so for that, what we need is an L293T chip. And what this will do is this will allow us to control two motors at once. So we can wire those in to this, and we'll have the ability to control those two motors. Let's see what I'm doing in terms of time. So I have another diagram like this. You'll notice that in this diagram, it's using the battery pack as well as the board, whereas in this one, it wasn't using the battery pack. And the reason for that is these motors take a lot of energy, and so you're getting a 7-volt connection, I believe it is, if I'm not mistaken, instead of a 5-volt connection, to give the motors more energy. And again, to remind people, I'm not an electrical engineer, so I know I'm using the wrong term, and I apologize in advance, but that's the philosophy behind it. So I can go ahead and stop here, and what I can do is I can go ahead and I can kind of give a little demonstration. So actually, I'll go ahead and keep sharing my screen. So assuming that it's still running and I don't have any SSH issues, good. So what we can do is we can go ahead, we can open up the project, and if we were on npm start, it'll go ahead and start itself because we're using Node and because that's awesome. And here, let me see if I can pull this up now. Gotta turn off my background to show. So this is an example of what it actually looks like. You can see here where we have our board, where we have our Raspberry Pi, and then this is feeding into what's called a breadboard, and this allows us to kind of take that fritzing diagram and implement it without having to solder anything or do anything like that. Have a bunch of jumper cables here, cheap Micro Center stuff, and then you can see where we have our battery pack over here, and that's wired into the board as well, right? So we have a go back to the background. Actually, probably not. So what I can do is if I, sorry, forgot to put the sudo in front of it. So if I start this up, and I go to my browser. Oh, sorry. Assuming everything works. Live demos are always questionable, right? So we get a little web UI, and sorry, I didn't have time to make it look all flashy. I was actually going to try to do a joystick and everything else for it, but I left it fairly simple for now. So you see where we have commands: forward, backwards, right, left, stop. So for example, we can send commands, and hopefully this works. And I don't know if you saw it, but one of the wheels is messed up. But we're getting commands where the wheels are moving forward. And then we can hit stop, and it'll go ahead and stop the wheels. And then we can hit backward, bring them backward, right. One will go forward, one will go backward, left, one will go forward, one will go backward. And then again, we can stop. And so what we've done here is we've taken a really simple Koa application and we've wired it into these Pi and these Pi GPIO libraries that we're talking about. Oops. And now we have the ability to, should have thought about this one a little bit more. I can't, there it is, wrong one. Now they have the ability to communicate directly to the machine. So that's good. Now we've got our basic robot, right? Which is awesome. Now we can send this around the house and we can start bugging people and do all kinds of things, but it's not, I mean, having 2 motors and a LED that you can flash is cool, but it's not that amazing, right? So let's start looking at where we go from here, right? So from here, what we want to start talking about is the nervous system of the robot. So we have different parts that we need, right? So we're going to talk about things like servos, stepper motors, right? Because that one isn't really a stepper motor. We have sensors, right? Like temperature and LiDAR, things like that. Device buses, like what we were talking about in terms of the I2C stuff, where we can have tons and tons of different devices on the individual circuit, and like motor controllers and things like that. So the first thing what we need to talk about is we need to talk about what's called PWM and serial communication. So what is PWM? PWM stands for pulse width modulation. And what that means is that instead of having a like stable low or stable high, you instead have what's like a wave pattern. So if your baud rate, right, is a certain thing, then half of the time it'll be on and half the time it'll be off, right? And that's a 50% duty cycle. You can change your duty cycle numbers to be more on than off, more off than on, things like that. And the easiest way to kind of visualize this, I think, is with LEDs. So I have a little video here where it just shows when you're using pulse width modulation, you can do things where you are flashing, or the LED is getting brighter and dimmer. And the reason that works is because it's tricking your eye. It's not necessarily that the LED is dimmer or brighter, it's that it's brighter for longer of that cycle, or dimmer for longer of that cycle. So it tricks your eye into thinking, instead of it being off for that period of time because it's so fast, that instead it's just dimmer for that period of time. So, and that's another thing I wanted to do with the demo. So with that, that's one of the reasons. Can you guys see me on the camera when I have the thing open? Does anybody? Hold on, I don't have. You guys?
That's it.
Yeah.
Okay.
You're showing up on Twitch as well. You're in the top right in a little box.
All right, cool. Sounds good. So when we look at this, we can go ahead and, if I get out of here again, go back to here. and we can say something like this, and it'll go ahead and turn the, I don't know if you can see that in the video or not, but you can see where it turned the color purple, right? And the reason that that can happen is because all of the different LEDs, it's an RGB LED. With pulse width modulation, they can all operate at different light levels. And so you can use that duty cycle to go into your RGB value, and then you can use that to dim or lower the individual values, right? So in this case, in the demo app, you can put whatever color you want to in here. If I want to put green, right, and it'll turn to green, right? And so the reason that's happening is because of pulse width modulation. It's taking this red, this green, and this blue, and the blue LED, and they're you know, using a duty cycle to make the color actually work. On the back end, that's actually coming from a Node.js library called Color to RGB that allows you to put any color in and get a sorry, one second. Might as well turn it off, and get a RGB value back. And so the nice thing about that is that I can you know, translate that RGB value almost directly into my duty cycle, and then that allows me to get the colors that I need to do that kind of functionality. So that's where we're starting to talk about serial communication, right? So now we can take that and we can start sending messages through that, right? So we can serialize messages into this pulse width modulation, right? And so that's where we start getting into things like UART, which, oops, sorry, I went ahead. UART is a typical bidirectional asynchronous transceiver or receiver and transmitter protocol that's been around forever. It's been around since 1971. This isn't new stuff, right? But it provides the ability to communicate over, you know, a serial port basically within a board. So what's interesting about this is you'll see a lot of videos on YouTube where people will look at patent filings and stuff like that and figure out where they originally had the UART ports mounted so that they can go back, remount UART ports, and just interface with whatever device we're talking about in general. So it's a really good port to have on your board because you'll be able to get a lot of information out and maybe even get like a shell or something out of it. But again, this is all based on a baud rate. That baud rate is what that cycle time is. So what's the time between the beginning of that wave and the ending of that wave, right? So you have to understand what that baud rate is, or you won't understand how to communicate within this serial environment. It's interesting because a lot of these things, especially sensors, they use what's called a telegraph high. And the reason it's called telegraph high is because that's how telegraphs used to work. It used to be easier to tell when a telegraph would go down as long as it was in a high state, because if it was in a low state, you never know if the telegraph pole went down. So they would put it in a high state. And then when the telegraph pole would go down, you'd know because it would go to a low state. And so now a lot of sensors do that too. So it's easier to understand when one of your sensors goes out or something like that. So a good thing to remember from that perspective. And as is pretty much a buzzword in every big data field these days, it uses what's called data frames to be able to send that information through that serial communication. So how are we doing on time right now? Oh, we're doing good. Okay, good. So one node library to use to actually interface with this sort of things, such as UART, or even some of the pulse width modulation stuff in terms of other just normal SPI interfaces and things like that, is node serial port. So it's a library where you pretty much just, I mean, you can see here where it's fairly simplistic. You import it, and then you can set the baud rate so that you're on the right baud rate. And then you go ahead and start reading off the stream, which is super nice. So plenty of node libraries to handle this. And probably the best one is node serial or node serial port. So we talked about 2 motors, right? But 2 motors are cool, but now we need 100 motors, right? So how do we do that? Okay, well, there's a pro, or I don't know if there's a protocol, that might be the wrong word, but there's a standard that's set up called I squared C. It's actually I squared C. I've been saying I2C. It's just easier to say I2C than I squared C. So that's why I say it that way. But it's basically like a simple serial bus. So what it does is it allows you to address multiple circuits that you have on that individual circuit. So instead of having to have a GPIO pin for each individual item, you can have a master and then a bunch of kind of slave nodes that go out. The real problem with this, so it was originally designed in 1982, right? So again, none of this is new. Nothing that we're talking about here is like too cutting edge. It's governed by the NXP. And the real problem here is that what you'll run into sometimes with this that you have to be careful of is if it's the same device, sometimes they'll use the same address. So it might be difficult to handle it in that way. And there's other bus solutions that you can use for those sorts of cases, right? But this gives us the ability to have like a really large amount of sensors or motors or whatever we need. A lot of people, when they're using Raspberry Pis, they'll use this for talking to their light strips when they have one of those light strips, because those use I2C a lot of times. So this is really about being able to get a lot more items onto the actual robot itself. And as I said, it's a typical master-slave design. So the master generates the clock, which so the clock is going to be the basically kind of like the metronome for the entire bus, and then slaves will go ahead and respond based on what's sent over that from the master. So here's an example of how to use the node I2C library or I squared C, as we just talked about, to communicate with an I squared C device. You can see here where it has this /1 to represent that it's pointing to the first device. You can see that that we're basically writing bytes out to that stream. And then if we receive bytes back, we go ahead and read them there. But that's basically how this works. So I didn't actually do this one. This was kind of like a cut and paste. So, but it's just, I just wanted to put an example of how to communicate with I2C there. Okay, so the next thing we want to talk about is Arduino. When we're talking about Raspberry Pi, one of the limitations of Raspberry Pi is it's digital only. So sometimes there's some things that are better done through analog signal. And one of the nice parts is that the Arduino boards, they support the analog signal. And the other nice thing is that they support the serial interfaces that we can use, like USB, to communicate back to our parent board, if you will, our Raspberry Pi. So that's a really important use for the Arduino boards. Even if you're using the Raspberry Pi, sometimes you'll want these for the analog pens. And like I said, it plugs right in, no problem. You don't need a power supply or anything, because the USB self-powers it, and you can plug it back into the Raspberry Pi. Another thing to talk about, I kind of forgot to mention this too, but if you notice on my robot, I'm using like a cell phone battery as the battery supply for it. As long as it's a 5-volt cell phone battery, 5 volt or higher, you'll be able to use that for the Raspberry Pi board. And that, assuming you're not pulling too much out of it, it should be fine to also run the Arduino board off of it. So I wanted to talk about, because we're talking about Arduino, I wanted to talk a little bit about Fermata. Fermata is a application that you can install on your Arduino board that allows you to communicate with the actual Arduino itself. So typically what you would do is you would create a sketch file and you would upload it to your Arduino board. But with this, we want to do something a little bit more dynamic. And instead of just writing to the actual serial ports, we can use Fermata to provide us kind of a deep integration with the actual Arduino board from our actual robot application. So you can see here where we have a TTY address for the USB device, right? And then we go ahead and we can just use that in this Arduino Fermata library. Assuming Fermata is installed on the Arduino board, we can use that to actually just connect and then start writing out code directly to the Arduino itself. So this is a really useful tool when you're trying to work with some of those things that don't necessarily work very well with the Raspberry Pi. You can bring them right in on another on an Arduino board and just daisy chain it basically. Now another thing I want you to remember, and this is kind of like the final topic pretty much that we have in here, is that JavaScript sucks at math. And the real problem with that is that a lot of the stuff we're talking about here, we're talking about really math intensive things, and we're talking about things that need to be quick, because especially if we're going to make something like a drone or a quadcopter or something like that, it's really important to be able to handle these things as quickly as possible, right? So for that, Node has what's called the NAPI. And what this does is this allows us to interact with actual other native libraries. So what we can do is we can use this NAPI header file, and as long as we structure our native code in the right way, we can go ahead and provide basically like a module export for native classes. So there's also a V8 header file, and you can actually run it through the V8 header file, but this header file is a little bit more specific for Node. So, and it does align with ES Next, that's what I call it. I don't know what everybody calls it these days, but so you can use the all of the ECMA module loading and all of that stuff, type of stuff. So yeah, and typically people use C or C++ with these libraries, and there's even better wrappers if you're using C++, right? Just like everything else. So like I said, the advantages with this is we can use any native library that's out there. So just like with Python, when you need to use something native, you can just pull it in with that. Same thing with Node. It does require a little bit of native code and integrates with other C and C++ libraries. So one thing about this is you have to define the node or the version of NAPI that you'll be using in your header file. So it looks similar to this. Just make sure you keep an eye out for that. So when we're setting up this native stuff, there's two different choices for actually compiling this native code so that it can be ran within a Node application. Those two choices are Node JIP and Make.js. The JIP is a pretty old famous build library, and it's used by Node and some of the other ones. And then Node JIP is just the Node version of that. It's what's used to build things like Chromium, V8, stuff like that. So, but they have been switching to a new one called Gin. So we'll see how that goes. But I tend to, because I'm from kind of, I guess, the old school or whatever, I tend to be more of a CMake person. So another option that's out there is CMake.js. And so I tend to use that as my build library. And if you look at the code that's in that Pi serial example GitHub repository that I mentioned at the beginning, that has some examples that are using CMake.js. So I don't have the Node JIP ones on there. So that's the one I typically go for. CMake, because CMake has a lot of documentation just because it's CMake. So you can tend to find things a little bit easier, and both can handle the NAPI builds, so it doesn't matter which one you use. A couple other cool libraries that I didn't talk about today because of time, because we're already 10 minutes till the end, and I want to show a little bit of code and take a little bit of questions. But Johnny 5, which is an awesome library that kind of some of the extra stuff I've done to kind of construct these robot objects. There's a lot of things that can be extended out of Johnny 5. A lot of that work's already done through that library. I was using a more basic library so that it's easier to show you guys kind of what's happening on the more basic side of things, but that's a great library. Pi SPI helps you talk for the SPI, which is a serial interface. So it's great for communicating over some of those serial protocols. And then Cylon, which is a really cool library that helps you maintain multiple robots at once. So a couple really cool libraries to check out. And hopefully you got out of this, you got that we defined what a robot was, defined how we were going to demonstrate it. We used Node to show how to develop one. We looked at kind of what are the next steps, what else can we look into in terms of this in order to start taking this to the next level. And again, there's the link, a couple other great resources, things like that. One other thing I wanted to go through real quick is just going through the actual project itself in case you decide to download it, just so that you understand how things work. If you go ahead and clone the repository, you'll see that there's a few different folders, including a 3D printing folder where I put the models for the actual body that I printed off. If you decide to go that direction, there's some folders for different Arduino examples, different diagrams and stuff like that I used in the presentation. If you go into the robot section, that's where the majority of the libraries are. I was originally going to do something with Python and Node, kind of showing the difference. Didn't really get there given the time, but that's available inside these folders. But the real one that you want to go into is Node and then UI. And just like you saw here in my SSH example, once you go in that UI folder, you can go ahead and do a node start, npm start. Make sure you're doing it as a sudo, and it will go ahead and run the application. In terms of, like I said, in terms of the wiring diagrams and everything, those are available. Those are available through the different diagrams in the documentation on here. In here, you'll see that we have the basic server application. And let me see, there we go. And then this will actually create the robot, right? So we create a new robot. That robot is defined inside this index file. And for this robot, we can define that it has one regular LED, one RGB LED, and one dual motor L293D board. And I've got this defined. Like I said, that's one of the reasons I didn't want to use Johnny 5, because I thought I might abstract things a little bit too much, and it'd be nice for people to be able to get a little bit deeper into it. So all of that code should be available on here, where you can go back and you can actually look at how we broke down the pins on the motors and everything like that. So hopefully all that information should be available. I have another version right now, which is the sensors version, which shows how you can use some of this pulse width modulation stuff to communicate with a proximity sensor that can tell when there's something in the way. Another cool side note that I wanted to get in this presentation that I really didn't have time for is Google has an AIY platform that you can use to actually integrate this robot with some of the Hey Google style commands and things like that. So that's another interesting topic to look into. But that's basically all I have from the robot perspective. Do we have any questions to start with? You're going to run that for me, right? Right, Guy?
Yeah. There's no questions on Twitch right now. So we actually have 3 viewers on Twitch. So
Oh. We
I
almost
think
made
we
double
peaked to
digits.
7 though, so that's good.
Oh no, we did make double digits then, unless
Did we?
somebody's on here and on Twitch.
Mhm.
How's it going, Greg? I haven't seen you
Jackie.
in a while. How you doing?
Yeah, it's been a while. Yeah,
Long time no see.
yeah, just we stay at home. Just thought, outside's overrated.
I don't think we have a choice now.
Mhm.
Well, you can still go outside. I went camping over the weekend or last week.
Nice.
I have not been the best about my quarantining, so
Yeah.
I swam in a muddy lake. So,
Yeah.
good, Greg.
I have to say, yeah, I'm actually on vacation right now for a week, and yeah, I'm just staying at home, sunny Grove City.
Sunny Grove City.
Yeah.
So I have a fun question.
Sure.
What's your next project that you're going to work on? What are you thinking about doing next?
That's a good question. So a lot of the reason that this came about, this presentation was, like I said, I had done this robot stuff before, and then I had, kind of put it on the back burner, and then my daughters are getting a little older now, so I wanted to start, coming up with material for that. So I think that the next step is, like I said, kind of taking these and kind of integrating them into like an AI platform, which is what I really want to start working on. So using these sensors to kind of feed into an AI model, using multiple sensors in that model, and then kind of trying to figure out how to make something that drives itself a little bit more. I have an electric car, so I'm really excited to try to get like hack the CAN bus and start trying to see what I can, do with that. So that's the kind of the direction that I'm going with that.
Does anyone else have any fun projects that they've been thinking about doing that Jackie could help with?
Well, I do have a couple of room bars I don't have a use for anymore, so I might mess with those at some point.
You should open them up and see if they have a UART port. They might.
Yeah, it's very likely.
It's pretty fun to just figure out, how they do it.
Yeah, and the AI thing is actually probably an angle I could attack, because if there's one thing that can be useful, it's catching users.
Well, and that's why I really want to, like, I didn't have time to get into it too much for this presentation, but I want to start like looking at that Cylon library a little bit more, because I have a bunch of, like, for educational reasons too, I have a bunch of, and for fun, because I have a R2D2 one, I have a bunch of the Sphero robots that came out, you know what I mean? Like the Spark and all that. And with Cylon, it integrates right with all that, and you can kind of create your own cluster of robots. So, like, I think that would be fun to play around with.
Oh yeah,
like swarming behavior.
Kind of like Big Hero 6 or whatever. That guy's robots on there.
I've been noodling on a couple different projects for a long time, and I'll get around to them someday. I've always wanted to build a weather globe, basically it's just an LED and a Raspberry Pi, and it just checks the weather every couple minutes, and pulses gently if there's going to be rain, gives a color between blue and red to give you an idea of whether it's going to be cold or hot. Turns yellow and flashes in patterns of 3 if there's a weather hazard, that kind of stuff. Always thought that would be kind of a fun project.
That reminds me of a building that they have in Boston that does that. There's like a Prudential Center that you can tell the weather by the light on top and how it's.
Yeah.
Well, that's neat.
That's actually easier in Ohio, though, because you just use a random number generator.
Yeah.
So, and one other
thing, it just pulses all the time because it always rains.
One other cool thing is, I didn't really mention it, but it's awesome. There's a manufacturer called EIGO, or I don't know if he's a manufacturer distributor, but like they have boxes of those sensors that you can buy for like $20. You get like a temperature sensor and all those things. So you might be able to hook one of those up and just do it that way. Yeah.
I have 2 other projects that I've always kind of wanted to do. I've always wanted to create sort of just like a home dashboard, like, do some etched aluminum with LEDs and toggle, the nice metal toggle switches and stuff like that, and use that as sort of a display data that I have about my life that's in the internet, and put it in my physical world. So like I could have like my bank balance and how many emails I have, and then LEDs that show me the status of different things, and some toggle switches, just because it'd be kind of fun. Sort of like a personal dashboard that's hardwired. But the thing I think I've played around with a bit is consuming like Twitter feeds and that kind of stuff and displaying them on as Morse code. And then create like a Morse code sounder that like taps out tweets that have a particular hashtag or whatever kind of news feed you want to,
Ooh, colors based on how many capitals they have.
Yeah. Yeah. But then that also leads to the idea of like, well, I kind of want to create a telegraph key. Like, I mean, creating a USB telegraph key would be kind of fun because then, it's like it's typing the hard way.
Well, there you go. That's like just a practice in SPI or in serial communication. All you got to do is make it an input, run it high.
Yeah. So it's that kind of stuff's kind of I think that'd be a fun alternate keyboard. So I like taking modern formats and shoving them through to really ancient formats. There's a joy in that, right? There's a absurdity.
There's no reason you actually have to have a key. You could just listen for a sound. So just recognize the tapping sound on the table.
I was thinking you might be able to build a neural network that could listen to Morse code and spit out text.
There you go. That's a good.
But I think that problem's been solved already.
Oh,
so pretty sure any tapping sound would be hard to signal out.
Yeah.
Filter out.
Well, Guy, if you're into that and bringing old machines back into the new age, I have a Magnavox Odyssey sitting in my closet back there.
Here, I'll show you
something. To figure out how to get that hooked up to a modern TV. So
but before we do that, I should probably sign us off of Twitch because we're still streaming on Twitch. So and 2 people are viewing us right now. So I think this is the part where I say thank you very much for your talk, Jackie. We're going to hang out for a bit a while longer. Anyone who's on Twitch that's not on the Zoom, you're welcome to join us. If you join the Discord, you can get the URL to Twitch, and I'll post the Discord URL in the chat on Twitch one more time in case you want to do that. There you go. And now I'm going to go say thank you very much, Twitch, for joining us, and see you in a month.